Welcome to The Explainer. Today, we are pulling back the curtain on AI engineering, breaking down what it really takes to go from a cool demo to a real, rock-solid application using generative AI.
And it all kind of starts with that moment we all shared, right? The ChatGPT moment. As AI expert Chip Hewen says so well, you can immediately see the incredible power. It was almost disorienting, but the actual path to using it to build something, that was a lot less clear.
So, that feeling, that disorientation, it left basically everyone in the tech world asking the same massive question. How do we go from watching what looks like a magic trick to actually manufacturing that magic reliably, day in and day out?
And the answer that's emerged is a whole new discipline, one that's giving us the rules, the structure, and the processes for this new era. And that discipline is AI engineering.
So, what is it exactly? Well, at its heart, AI engineering is the whole end-to-end process. It's about taking one of these huge, powerful foundation models and skillfully adapting it to fix a real problem you have. The key is that it's a mix. It combines those classic, battle-tested engineering principles we've used for decades with a whole new set of techniques that this AI age demands.
And this is where you see a really fundamental shift from what we used to call machine learning. You know, before, engineers would spend months painstakingly crafting features from data and training models from the ground up. Now, the game has changed. The focus is on skillfully adapting these massive pre-existing models using brand new methods like prompt engineering and context construction.
And let me tell you, this shift is happening at a truly incredible speed. The developer community is jumping on this faster than almost any technology we've ever seen. I mean, look at this. On GitHub, which is the home of open source code, AI engineering tools are gaining traction and popularity even faster than titans like Bitcoin or the web framework React ever did. It's wild.
Okay, so if we're going to be builders, we have to know our materials. So let's start this journey by looking at the fundamental building blocks you'll be working with.
And your core material? It's the foundation model. Now, these are not the specialized single-task models from a few years ago. No way. Think of these as powerful, general-purpose engines, you know the names, GPT-4, Llama, Claude, that can be pointed at a huge range of tasks right out of the box.
And their versatility is just staggering. On the consumer side, you see them writing our emails or acting as AI companions. And in the business world, they're doing everything from powering customer support and acting as co-pilots in products to doing really complex market research and organizing huge vaults of company knowledge.
But all of that amazing power brings us to the first major roadblock for any AI builder. Before you even think about writing code, you need a blueprint. You have to define what good actually looks like, and this is the crucial part. Figure out how on earth you're going to measure it. And this is so much harder than it sounds. In fact, our source material states it plainly. Evaluation is one of the hardest, if not the hardest, challenge in all of AI engineering. And why is that? It's because the model's output is often creative, it's nuanced, it's subjective. Simple right or wrong metrics they just don't apply.
So how do you solve what might be the hardest problem in a field? You get systematic. You build a dedicated evaluation pipeline. The whole goal here is to turn that fuzzy feeling of, is this output any good, into something objective and repeatable. It starts by testing every single piece of your system, not just the final output. Then, you create crystal clear, human-readable guidelines for what a good answer actually is. Is it helpful? Is it safe? Is it in the right JSON format? And finally, you define the exact data and methods you'll use to test against those guidelines, again and again and again.
Okay, so you've got your blueprint. You know how to measure your work. Now it's finally time to pop open that toolbox and start shaping the model to do exactly what you need it to do.
And inside this toolbox, you've got two main techniques. The first is called Retrieval Augmented Generation, or RAG. The best way to think about this is like giving the model an open book exam. You're giving it external knowledge, a cheat sheet, right when it needs it. The second technique is fine-tuning. Now this is different. This is more like teaching the model a whole new skill, changing its internal behavior, or even giving it a specific personality.
And the absolute key is knowing which tool to use for which job. And thankfully, there's a perfect, super memorable rule of thumb for this. Fine-tuning is for form, and RAG is for facts. Use fine-tuning to change the model's style, its personality, or the structure of its output. Use RAG to give the model fresh, up-to-date information that it needs to be accurate. Form versus facts. That's the mantra.
All right, we've got our materials, we've got our blueprint, and we have our tools. So now let's pull the camera back and see how all of these pieces assemble into the complete structure of a modern AI application.
You see, a real-world AI application isn't just a model. It's a full stack. At the very top, you have the application layer. That's the user interface, the prompts the user interacts with. In the middle is that whole model development layer we just talked about, with fine-tuning, RAG, and that all-important evaluation pipeline. And holding it all up is the foundation, the infrastructure layer, responsible for actually serving the model, caching results to be fast, and monitoring performance.
And this all leads us to a final and pretty provocative thought. If your data is the foundation of the building, and evaluation is the architect's blueprint, does that mean the AI model itself, the part that gets all the headlines and all the hype, is actually just another component in a much, much larger engineering system? Maybe even an interchangeable one? That's the question every single AI builder is grappling with right now.